Hello students and welcome to lesson 4.1. Okay, 4.1 we're going to talk about congruent triangles and congruency statements and something called CPCTC. So triangles with the same angle measures and congruent sides. That's what makes them congruent triangles. Okay, so they have to have three pairs of angles that have the same measure, and three pairs of sides that have the same length, and then we could say that the two triangles are congruent. Okay, so this means that all corresponding parts are congruent. Okay, so that's, again, angles and sides. Okay, now congruency statements. When triangles are congruent, we can write a congruency statement which looks just like this. So if you notice the markings on the triangle, if I look at angle A, from the statement, I really don't even need the diagram. If angle ABC is congruent to triangle, did I say angle? If triangle ABC is congruent to triangle DEF, then I know right away that A and D are going to be congruent. And as you can see, they have the same marking. I can also see from the statement that angle B is congruent to angle E, and they have the same marking. And of course, C then and F would be congruent. Also notice the sides. If I look at side AB, I should see the same congruency marking as DE. So here's AB and here's DE. Also for BC, has the double tick mark, and EF has the double tick mark as well. And then for AC, we have the triple, and AC corresponds to DF. Okay. So, a valid congruency statement must match all corresponding angles and sides. So CPCTC, what that stands for is corresponding parts of congruent triangles. That's a terrible triangle symbol there. Are congruent. We will use this in our proofs later on, okay? But basically what it means is that if we know that two triangles are congruent, then we know that every pair of corresponding parts is also congruent. And you'll see how we use that in the proof later on. Okay, so for now we're going to list all congruent angles and sides given the congruency statement. So again, with this statement, I don't even need a picture. I know right away that if this statement is true, then J corresponds to P, which makes angle J congruent to angle P. Angle K is congruent to angle Q. Angle L is congruent to angle R. For my sides, I have JK, which corresponds to PQ. So I know that JK with the bar is congruent to PQ. Okay, then I can go, the order of how you write things is very important, by the way. If I say KL, then that would correspond to QR. If I say RQ, that would be wrong, right? Because again, Q and P correspond. So your order is very important. Even though these are segments, you might be thinking, well, why does it matter? These are segments. I thought we could write them in either order. But now we're talking about corresponding parts. So your order is very important. The last set of sides then would be JL. And JL is congruent to PR. Now, I could reverse it. If I say LJ, I can say that's congruent to RP. Okay, that would be fine. Just as long as your corresponding parts are matched up, that's what's important. So we can write another congruency statement. When you're asked for a congruency statement, it means about the triangles. So we use our triangle symbol, and I'm just going to change up the letters. Actually, I'll just go in reverse order. So I could say LKJ is congruent to triangle RQP. And there's other possibilities as well. As long as your corresponding parts are matched up, that's what's important. So go ahead and try number 2, pause the video, and when you're done, come back and we'll compare solutions. Okay, let's see how you did. Okay, go ahead and compare. Make sure you have everything matched up. You might have a different congruency statement, and if you're not sure if yours is correct or not, you can certainly ask in class. Okay, so if you're done with that one, go on to number 3, pause the video, and again, match up all of these statements. You're doing sides and angles and triangles. Pause the video and then come back when you're done. Okay, here's the solutions for number 3. Go ahead and compare. And now these should all be exact. Okay, there's no other possibilities here. Okay, on to finding some actual values of angles and side lengths. So here again, I always look at the statement because these triangles could be rotated, reflected, a combination of different things. You can never go wrong by looking at the statement. So from this statement, I know S corresponds to B, T corresponds to F, W corresponds to N. So if I'm asked for BN, then I know BN has the same length as SW. And if I look at SW, it's 9 centimeters. So BN is 9 centimeters. TW, when I look at TW, that corresponds to FN. Okay, here's FN. So that's 14 centimeters. BF corresponds to ST, which is right here, so that is 17 centimeters. The measure of angle W. W corresponds to N, so that's 82. Angle B corresponds to angle S, so that's 67. And F corresponds to T, which I don't have an angle T, but of course I can find that measure by adding these two together. That's 149 subtracted from 180, which is 31 degrees. Okay, now go ahead and try number 5. When you're done, pause the video, and when you're done, come back and we'll compare answers. Okay, here's the solutions. So go ahead and check your answers. If you got anything wrong that you're not sure about, please ask in class. Okay, let's try this one. Now we have some algebraic expressions. So again, I'm just going to look at this statement. Okay, that's the best way to go because again, these triangles could be flipped around or rotated. So let's see. I have an expression for UV and UV corresponds to TS. Okay. So that means that 12x minus 7 is equal to 53, which means 12x is equal to 60, and x is equal to 5. Okay, to find the value of y is RS. So when I look at RS, that corresponds to WV, and here's WV. We can do this in red. Okay, so 5y minus 33 is equal to 57. So 5y is equal to 90. Okay, so y is equal to 18. And then lastly, I just want to double check this for z. Z is in the expression for side UV, or UW, rather, and UW corresponds to TR, and that's what we're left with. So we have 3z plus 14 is equal to 50. And I'm subtracting, so that would be 3z equal to 36. So z is equal to 12. So go ahead and try number 7. And when you're done, come back and we'll compare solutions. Okay, go ahead and check your answers. And again, if you have any questions, make sure you ask in class. Okay, 8 and 9. So now there is no triangle, okay, but you're given all of the information. Just make sure you're pairing up the corresponding parts, okay, and solve for x and y. So go ahead and try 8 and 9. Pause the video, come back when you're done, and we'll compare solutions. Okay, let's see how you did. So there's the solutions. Okay, so DE corresponds to JK. Okay. Given information about EF. Okay, EF corresponds to KL. DF corresponds to JL, and so excuse me. So again, just go through, check the work, and then make sure to ask questions if you have any. So this completes our lesson for 4.1. We'll be working on 4.2 next, okay, which is related to isosceles triangles. So I hope you enjoyed the lesson, and I will see you in class.